So, for the problems for the homework tonight, we're supposed to use the physics problem solving format. Please make sure that you read through those. For each of the problems, we need to draw a picture. So for this one, we've got a running at a constant speed. If a horse ran 84 meters in 12 seconds, what's the average velocity? So we need to define our system as the horse. We want to label the starting position as 0 meters. Let's say to the right is positive. And we want to find out what the average velocity is for this problem. They want us to define a system. We've done that. The position of 0, direction of positive. List the given information and what we're supposed to find. So in the given information, we have 12 seconds. We have to determine what that represents. Let's say that that represents the change in time. 84 meters represents our displacement. If possible, draw position versus time and velocity versus time graphs. If we assume they start at 0 and it's a positive constant velocity, we have a shape like this. And for this as well, we do have the final clock reading of 12 seconds, so we can include that value. We don't know the initial velocity or starting, we never know the starting position is 0, but we don't know, we know the ending position is 84 meters. So we have that information there. So next up, use the general equation to fill in original values of units. We need to find the velocity with the change in position and change in time. Well, we happen to know that the slope of a position versus time graph gives us the velocity. So we can write the general equation. Average velocity is equal to the change in position divided by the change in time. With our given information, we said the change in position was 84 meters divided by our change in time, which is 12 seconds. And 12 goes into 84 and we'll use 7 times 7 meters per second. And we're going to put that in the box, that answer. And representing that, finding the average velocity is 7 meters per second. Great. And keep in mind as we go cranking through these, I'm going to work through these quickly. You can always pause, rewind as necessary. This one says a dog ran at a constant velocity of 5 meters per second for 14 seconds. How far would it travel? So they're asking us to find displacement. 14 seconds is the change in time. 5 meters per second would be an average speed or average velocity. Again, if we assume the starting position is 0, we're moving in a positive direction. We can say that our position versus time graph would look like this. Our final clock reading is 14 seconds. The velocity versus time graph also ends at 14 seconds. We happen to know the velocity is 5 meters per second. Second over here. And we need to find the displacement. Well, for this one, to find displacement, all we have is this stuff about the velocity versus time graph. We could use the area under the velocity versus time graph. So we know that the area under the velocity versus time graph is the displacement. So the area of this rectangle is the displacement. The area of any rectangle we know is height times base. In this case, the displacement is the height, which happens to be the initial velocity of this dog, and our height, our base would be our change in time. The initial velocity would be 4 meters per second, and our change in time was 14 seconds, and 5 times 14, 5 times 10 is 50, 5 times 4 is 20, so that looks like it's about 70, and a meter per second, seconds cancel out, and so we get 70 meters is the displacement. Again, going through the process, we identify the system, starting position, what direction is positive, the given information, what we're asked to find, sketching position versus time and velocity versus time graphs before we go solve the problem, starting with the general equation, filling in original values with units, and solving. How long would it take for a hawk to travel 52 meters at 4 meters per second and show your work? Again, this looks like if we say the starting position is 0 here, we say to the right is positive. So similar shape for our position versus time graph. We know that the final position is 52 meters. We don't know the final time. If this is a positive constant velocity, our velocity versus time graph looks like this. And we know that the height of that graph would be 4 meters per second. They give us 52 meters, which is the displacement with velocity of 4 meters per second, and we're asked to find how long it would take. So we're trying to find change in time. So for this process, I think we're going to have to go back and use the area under the velocity versus time graph again, which is the displacement. So we know that the area of a rectangle is height times base. We've previously established that the area under the velocity versus time graph is the displacement. The height of our rectangle is our starting velocity, and our base is our change in time. In which case we've got 4 meters per second times change in time equals the displacement of 52 meters. So to find change in time, we have to do the opposite of what's being done to it right now. We're taking change in time times 4 meters per second. So we'll have to divide both sides by 4 meters per second. And 4 meters per second divided by 4 meters per second, those will cancel out. And so now we've got just change in time on the left. And 4 goes into 52, 4 goes into 5 once. And there'll be 1 left over. 4 goes into 12, 13, or 3 times. And so we've got a meter per second divided by meter per second. That's meters per second divided by meters per second. And you may have remembered from math class, whenever you divide by a fraction, it's the same thing as multiplying by the reciprocal of that fraction. In this case, we now have meters on the top and bottom of that fraction, which cancels out, which leaves us with just seconds, which is really good because that's what we were trying to find with change in time. 13 seconds is how long that would take. And for our last problem here, it looks like we got a bowling ball hitting an alley at the 1 meter mark. Looks like that marked that at 2. So we'll say this is the 1 meter mark and it's heading down towards the pin. I don't know that my scale on my drawing is very good. I'll put a constant velocity of 3.5 meters per second. Our change in time is 3 seconds. In this case, we've got it started at the 1 meter mark. So we've got a positive y-intercept here. It still would be a positive constant velocity. Hi. And I'm taking it right now. Thanks. So our change in time is 3 seconds. Our velocity is in meters per second. I have in seconds. And they asked us to find where it would be. Find the final position. Well, to do this, we're probably going to want to consider our position versus time graph. And we knew that the starting position of the y-intercept was 1 meter. So I like starting off with y equals mx plus b. We know that for our position versus time graph, that we can say position is equal to the average velocity times the clock reading plus the position at time 0. To make a specific mathematical number for this, we can say that position final is equal to the 3.5 meters per second times the clock reading of 3 seconds plus the starting position of 1 meter. Respecting order of operations, we need to do 3 times 3.5, which is 10.5 meters per second times seconds. The seconds will cancel out, which leaves us with just meters plus 1 more meter. And so our final position is going to be 11.5 meters, which is where that bowling ball would be in 3 seconds after this process there. Anyway, in review, for each of the problems, we drew a picture of the situation, defined the system, labeled where 0 meters were and which direction is positive, sketched out a position versus time graph and a velocity versus time graph. We've included values when we knew them. Sometimes one graph will help more than the other. The velocity versus time graphs tend to help more than the position versus time graphs do. We list our given information, including both the values and units and what they represent. Find the final position. In this case, we have to come up with an equation that has final position in it, with considering answer it, you